Let's start here in chapter 10.1 with number 5. Number 5 asks us to find the future value of $1,000, which is the present value, after 2 years at 6% interest compounded monthly. So we're going to use this formula here, and our formula is, I'm going to write it like this. Future value is equal to present value times 1 plus r over m to the mt. Now, r over m, this is just I, that's the interest, but this is the interest per period, times the number of payment periods. And now, let's just fill in the numbers we know. So what we want is FV, that's what we're looking for, equals 1,000 times 1 plus R, which is 0.06, right? 6%, compounded monthly, that's 12 times a year, raised to the 12 times, and we're doing this for 2 years. And we get a future value now of, all right, when I did this on my TI-84, I got 1127.16, 1127.16. So what this says is that if you put $1,000 now into an account that pays 6%, leave it there for 2 years, compounded monthly, at the end of 2 years, you will have $1,127.16. Now, in problem number 7, we are asked to find the present value of a future value of $100,000 payable in 25 years at 6% interest compounded monthly. So I'm going to start by writing our formula. Future value is present value times 1 plus, there's the interest rate per period, R, which is the annual interest rate divided by the number of payment periods, raised to the number of payment periods total. So this is going to be, when we put our numbers in, we're going to have 100,000, that's how much we want in the future, equals PV, that's we don't know, how much do we have to invest now, times this quantity, 1 plus 6%, 0.06, now we're doing this monthly, so 12 times a year, M is 12, let's see if we can make, we'll make that a 12, times 25. So we can solve this for PV, right, just by solving, by dividing by this number right here. So take 100,000, divide it by this number, and that will get us the 100,000 divided by that number right there. That is the present value. And when I do this on my calculator, I came up with, all right, so I got 22,396 and 57 cents. So what that says is that if we were to invest this much money right now and leave it in an account for 25 years, compounded monthly, paying 6%, 25 years, we would have our $100,000. Now in problem number 9, we're asked, or we're told this, $6,000 is deposited now into a savings account. All right, so there's our $6,000, that's our present value, into a savings account paying 6% compounded monthly, and for 3 years. What we want to know is find the balance after 3 years, and then, after we get that, how much interest did we make? So I always like to start by writing our formula. FV equals PV, future value, equals present value, times 1 plus R over M to the MT. And now let's put in the numbers we know. So FV, we don't know that. We're looking for that. So that's 6,000 times 1 plus 0.06 over 12 raised to the 12 times 3. And now, the future value on my calculator showed me, when I made that computation, I got $7,180.08. So that's one of the answers we're looking for. But then the other part of the question says, how much of this, right, how much of this money is interest? Well, look, here's what we did. We invested $6,000, and 3 years later, we've got this much money. So our interest, the interest, I think this should make sense here. Our interest is equal to the future value minus the present value, right? The ending value minus the initial value. So with our numbers, we're going to get the interest is 7180.08 minus the 6,000. So we're going to claim that the interest that we made on this money is 1180 0.08. And that's the answer to the second part of our question.